Hello. This video is to review how to classify triangles by side lengths. It also includes how to determine if a triangle is possible given the lengths of its three sides. For these notes, you will probably want a straight edge and a pen or pencil. If at any time you fall behind, remember you can always pause the video and continue on with the notes when you're ready. So first topic is how to determine if a triangle is possible. If a triangle is not possible, then you don't need to classify it. So you always want to check to see if it's even possible before attempting to determine the type of triangle it might make. Okay, we're going to do 3 small drawings. Again, if you need to pause this recording to make the drawings on your notes, please do so. We're going to represent the 3 possible scenarios for triangle side lengths. For all 3 of these, the longest side length, C, is going to be the bottom edge. In the first drawing, side A plus side B is going to be less than side C. So if that's the case, A and B must be really short sides. As you can see, they are too short to touch and make a triangle. They would just fall flat. So no triangle is possible if this is the case. Okay, scenario number 2. If the sum of A plus B is equal to exactly C, we also have a problem. If A and B add up to a length exactly C, as you can see, they will fall flat onto side C and not actually make a triangle. So again, in this case, no triangle is possible. In our third scenario, the sum of the 2 sides A plus B is greater than the third side C. When this happens, A and B are long enough to touch and make an actual triangle. So this is the only scenario where, yes, a triangle is possible. The smaller 2 sides must add up to an amount greater than the longest side. If a triangle is possible, then you're ready to continue on and figure out what type of triangle you have. So let's do some examples where we're going to determine if a triangle is possible. Example number 1, the side lengths you are given are 3, 4, and 5. Now, to do the side length test, you have to know which one is C. C is always the largest. A and B are the smaller 2 and can be interchanged. So in this case, 3 and 4 are the smallest 2 sides. So we're going to take the smallest 2 sides and add them together. So 3 plus 4 equals 7. Then we want to take the longest side, C, and do a comparison. 7 to 5. Because 7 is greater than 5, the sum of A and B are greater than C. In this case, remember the 3 dots means therefore, a triangle is possible. Let's do another example. Example 2. In this example, the side lengths that you're given are 1, 4, and 2. Now, they're not always going to be nice to you, and give you the sides in order. Sometimes you're going to have to look and find the C. In this case, the longest side C is 4. So we're going to take the other two sides, A and B, and add them up. So 1 plus 2 equals 3. Now that number we're going to compare to the longest side, which is C. And between 3 and 4, 3 is definitely less than 4. Because the sum of A and B is less than the longest side C, that means no triangle is possible. So that's the test to determine if a triangle is possible. You add the smallest two sides together and decide if the sum is larger than the third side always being the longest side. All right, so now that we know how to determine if a triangle is possible, let's get into classifying. We are going to classify a triangle by side lengths. The application of this is because certain triangles have certain qualities and theorems that go with them. So by determining the type of triangle, you then know what theorems and postulates you're able to use with that triangle. All right, again, we're going to do 3 small drawings, so be sure to pause the recording if you fall behind so that you can make the drawings. All right, so the first drawing we're going to make is a right triangle. A right triangle has a right angle or a 90-degree angle in it. C is always the longest side, and the longest side is opposite the largest angle. In a right triangle, the largest angle is always 90, so C is the hypotenuse across from 90. A and B are the legs, which are interchangeable. If a triangle is a right triangle, then leg squared, or A squared, plus B squared will be equal to C squared. And remember that A and B are the legs, and those are interchangeable. The only one that you need to be concerned about is C, which is the largest side. That always has to go by itself on the right-hand side. So C is always the longest side. So if A squared plus B squared does equal C squared, we have a right triangle. All right, scenario number 2. We're going to draw a triangle with an obtuse angle in it. So I'm going to draw a short side and then a really big angle, and then join the ends. Again, the longest side is opposite the largest angle. Since this is obviously the obtuse angle, C will be across from it. A and B are the legs and are interchangeable. Now, in the case of an obtuse triangle, A squared plus B squared is going to be less than C squared because the longest side is really, really long in comparison to the two legs. So if A squared plus B squared is less than C squared, you have an obtuse triangle on your hands. And remember, an obtuse triangle has one obtuse angle, which is the largest one. The third and last scenario is for an acute triangle. I'm just going to draw an isosceles type triangle. Isosceles can be acute or obtuse, but it's an easy one to draw. Again, on this one, regardless of whether it is obtuse, right, or acute, the largest side is opposite the largest angle. In this drawing, we're just going to put C on the right, and it is opposite whatever the largest angle is, and A and B are interchangeable. If a triangle is acute, A squared plus B squared will be greater than C squared because the longest side is really not very much longer than the other two. If it has this relationship, you can classify the triangle as an acute triangle. So those are the three types: right triangle, obtuse triangle, and acute triangle. All right, let's do some practice. On your worksheet, if the numbers get really large, feel free to use a calculator. Some of the numbers will be quite big. Okay, so we've been given a triangle with side lengths 2, 10, and 11. Remember that C is the one that goes by itself in the equation, and it's always the largest. So you might want to circle it and label that as C. The other two can be interchangeable, but they are A and B. All right, so the first thing you're going to need to do is determine if a triangle is possible at all. So you're going to take the two smallest sides, A and B, and add them together. 2 plus 10 is 12. Then you're going to compare that to the longest side, which is 11. 12 is greater than 11, so a triangle is possible. Once you've determined a triangle is possible, we can go on and figure out what type of triangle it is. Okay, so to figure out the type of triangle, we need to find a squared plus b squared and figure out what its relationship is to c squared. That's your formula. So a squared would be 2 squared plus b squared, which is 10 squared. We want to know what is the relationship to c squared, which is 11 squared. So when calculating, follow your order of operations. Do your perfect squares first. 2 times 2 is 4. 10 times 10 is 100. Exponents first, then add. 4 plus 100 is 104. Now on the other side of the equation, 11 times 11 is 121. So 121 is greater than 104. So we know that this is an obtuse triangle. All right, let's do another example. Example 2. You're given a triangle with side lengths 13, 5, and 7, and you need to determine what type of triangle it is by the side lengths. So first thing you're going to do is determine if a triangle is possible at all. So looking at your side lengths, take the longest one and designate it C. Then designate the other two as A and B. Either order is fine for A and B. So our triangle test is to take the smallest two sides and add them together. 5 plus 7, which is 12. And then determine that relationship with the longest side, which is 13. Now 12 is less than 13. So in this case, no triangle is possible. And you're done with the problem because you can't find the type of a triangle that is not possible. All right, example 3. You have side lengths 6, 8, and 10. First thing, determine if a triangle is possible. Our longest side length is 10, so that is C. 6 and 8 can be A and B respectively. To determine if a triangle is possible, add the smallest two sides, 6 plus 8, that is 14, and compare it to the third side, which is 10. 14 is larger than 10, so we know a triangle is possible. Okay, part B, we're going to determine the type of triangle. This is where we're going to use the formula a squared plus b squared and figure out what relationship that has to c squared. So a squared would be 6 squared plus b squared, which is 8 squared. We want to know how that is related to c squared, which is 10 squared. So perfect squares first. 6 times 6 is 36. 8 times 8 is 64. 36 plus 64 is 100. And on the other side of the equation, 10 times 10 is 100. 100 is equal to 100, so we have a right triangle. At this point in the notes, if you're confident you understand it, you may stop the recording and go on to do your practice. I'm going to do one last example on special request because sometimes the side lengths we're dealing with have radicals in them, and that changes the algebra slightly. So in this case, our triangle has side lengths 20, 13, and 4 radical 35. Before you can determine which side is the longest, you need to know approximately the value of 4 radical 35. Your calculator is fine for this. It turns out to be 23.66 and then a bunch of decimals. Well, at 23, it is still the largest number out of the pair. So 4 radical 35 is our C value. 20 and 13 will be A and B respectively. So first thing we need to do is determine if a triangle is possible. So we add the smallest two sides, 20 plus 13. That gives us 33. And then we compare it to our C value, which is approximately 23.7. Well, 33 is greater than 23.7, so we know a triangle is possible. Now we're going to determine the type of triangle. Remember your formula, a squared plus b squared. What is its relationship to c squared? So a is 20, so 20 squared plus b squared, which is 13 squared. What is the relationship to 4 radical 35 quantity squared? All right, we'll do the easy two first. 20 times 20 is 400. 13 times 13 is 169, and their sum is 569. Now, if you remember how to square a radical, you're really taking 4 times 4, so times itself, and then radical 35 times radical 35, the two radicands get combined. So 2 35s, one comes out, it gets multiplied by the 16. And 16 times 35 is 560. 560 is definitely less than 569. So this triangle is an acute triangle. All right, that concludes our review notes. I hope you found them helpful.